So we've seen how a magnetic field combined with a current in a wire can produce a force. And this force can be used to do work. In fact, this is the simplest motor. So, and the name of this phenomenon is called the motor principle. And here I'm talking about electric motors, not gasoline engines. But I like to think about all the things in our everyday lives that require motors, whether it's a simple fan that we use to cool ourselves off, or the fan in my computer, or my electric pencil sharpener, or my blender. We use motors all the time, and it relies on this, again, this idea that if I've got something with current and I've got a magnetic field, that force will be exerted, and we can use that to run a motor. Well, now I'd like to talk about the opposite side of that coin, and I'd like to talk a little bit about how electricity can be generated. So again, previously we had a current and an external magnetic field. Now we're going to look at what happens when, again, we have an external magnetic field. And we have a loop of wire. If we have both of those things and we move the loop, in other words, do work, all three of those things together, actually I'll go this way, all three of those things together can generate current. To have current, you have to have electromotive force or voltage. So really, we can generate both. Okay, so this can be done in a number of different ways. So, for example, you might have a magnetic field. Here, this one will be pointing into the paper. And it turns out that if we have a loop of wire, like that, if I take that loop of wire and I move it into the magnetic field and out of the magnetic field, current will be generated. And the current will move in one direction when I move it in, and it will move in the opposite direction when I move it out. Okay. Another scenario, I could have an external magnetic field like this one, and I could have a loop of wire like this. And if I have a metal bar and I move that metal bar along these rails, I'm changing the area of the loop. Here, the area of the loop is this. But as I move this bar, I increase the area of the loop. Okay, so that's another way that I can do that. Finally, there's a third way that I can generate electricity in this scenario. I'm going to try to draw something semi-three-dimensional here. So if I have an external magnetic field, so by the way, if I draw this, you should be able to tell which is north and which is south. We almost go out of the north and into the south. If I were to take a loop of wire. And rotate it this way, I would change the effective cross-sectional area. So there it looks like that, but you can imagine, let's see if I can get this to work. Nope. If you can imagine when I rotate it, it's oriented up and down like this. That's going to change the effective cross-sectional area of the loop of wire.